Welcome to the Explainer. We all face uncertainty every day. Well, today, we're going to learn how to fight back. We're going to talk about mapping out the future to make way smarter decisions, all with a powerful tool called discrete probability.
All right, let's just jump right in with a quick bet. Imagine someone comes up to you and says, "Hey, I bet you can't toss a coin and get 3 heads in a row." So do you take that bet? What does your gut say? It seems possible, right? Well, let's see what the actual math has to say about it.
So you run the numbers and, whoa, the probability of getting 3 straight heads, it's just 1 in 8. That's only 12.5%. All of a sudden, that bet doesn't seem quite so appealing, does it? Yeah, that's a bit of a long shot.
But here's the catch. Knowing that one number is helpful, for sure, but it's kind of like trying to find your way around a new city when you only know where the tallest building is. It gives you a reference point, but you don't have a map. You're missing the whole story.
So what if you could have that map? What if you could see the odds for every single possible outcome all at once? A complete blueprint of what could happen. Well, that's what we're talking about today. That's a probability distribution.
Okay, so how do we start building this map? Well, the very first step is to organize the chaos, We need a tool that lets us put a number on every single thing that could happen.
And that first tool has a kind of formal name, a random variable. Now I know that sounds a little intimidating, maybe a bit mathy, but trust me, the idea behind it is super simple. All we're doing is slapping a numerical label on each result.
So, for our coin toss game, let's call our random variable h, which will just stand for the number of heads we get. So instead of dealing with these messy combinations like heads, tails, we can just say h equals 1. Simple, right? The only possible values for h are 0, 1, 2, or 3. And just like that, we've taken something random and made it neat and organized.
All right, now that we've got our outcomes all neatly labeled with numbers, we're ready for the next big step, building that full map we talked about. This is the probability distribution, and this, my friends, is where you get to see the entire landscape.
And boom, here it is, our complete blueprint. Look at this. This tells a way more interesting story than just that one number we started with. Notice how getting 3 heads is actually just as unlikely as getting 0 heads. The real sweet spot, the most likely outcomes, are right there in the middle, getting 1 head or 2 heads. See the difference? We're not just making a wild guess anymore. We have a strategic map.
So where do these blueprints actually come from? How do you build one? Well, there are basically 3 ways. Sometimes, like with a fair coin, you can figure it out with pure theory and math. More often, especially in business, you'll build it from looking at past data, like old sales records. And sometimes, when you've got nothing else to go on, you rely on the best guess of an expert.
Okay, so we've got this amazing map. But a map with a bunch of different places you could go doesn't actually tell you where to go, right? We need one final tool, something that can take this whole beautiful map and distill it down to a single powerful number that screams, "Do this."
And that final tool is called the expected value. All it is, really, is the average result you'd get if you could play the game or run the experiment over and over and over again. It's the long-run average. And the way you find it is simple. For each possible outcome, you multiply its value by its probability, and then you just add them all up.
Okay, let's make this real with another game. Imagine it costs 500 rupees to play. You toss a coin 3 times. You get 100 rupees for every head, and 200 for every tail. So, if you get, say, 0 heads, that means you got 3 tails, and your payout is 600 rupees. Here are all the possible payouts, along with the chances of each one happening.
So what's the expected value here? We do the math. We take each of those potential payouts, multiply it by its probability, and add everything up. And the number we get is 450 rupees. Now, what does that mean? It means if you were to play this game again and again, on average, you'd walk away with 450 rupees each time.
And just like that, the decision becomes crystal clear. You have to pay 500 rupees to play, but you only expect to get 450 back on average. No way. That's a losing proposition. In the long run, you're just throwing money away. The smart move, don't play.
All right, this is cool for games and bets, but let's see how this toolkit applies in the real world. Let's look at a classic business problem and see how these tools can build a real strategy for making actual money.
So, let's talk about a newspaper seller.
Every single morning, they face this dilemma, right? If they order too few papers, they sell out early and miss out on potential sales. That's lost profit. But if they order too many, they're stuck with leftovers they can't sell, and that's lost money. So what's the magic number? How do they find that perfect sweet spot?
Well, they solve it by doing exactly what we've been talking about. They look at their past sales data and build their own probability blueprint. They can figure out, based on history, the chances of selling exactly 30 papers, or 31, or 32, and so on. This table right here, this becomes their map of what customers are likely to do.
And this is the big payoff. This is where it all comes together. What the seller does is calculate the expected profit for every possible number of papers they could order. And when they do that, the answer just pops out. The chart makes it obvious. Ordering exactly 33 copies gives them the highest possible expected profit for the day. Order 32, they make less. Order 34, they make less. That's it. That's the power of switching from just guessing to having a real data-driven strategy.
Okay, that's great if you have a ton of past data, like the newspaper seller. But what if you don't? What if you're starting something new? Well, the good news is you don't always have to build your blueprint from scratch. There's some handy, pre-built models for really common situations. It turns out a whole lot of problems in the world fall into one of two basic patterns. The first pattern is when you have a fixed number of trials, and each one is either a success or a failure. Think about quality control, checking a batch of parts to see how many are defective. The second pattern is when you're counting how many times something happens over a certain period of time, or in a certain space, like the number of customer calls a support center gets in and out.
And for each of these common patterns, there's a ready-made blueprint waiting for you. For those success/failure trials, you use something called the binomial distribution. For counting events over time, you use the Poisson distribution. These are like incredible shortcuts. They let you model the situation without having to reinvent the wheel every single time.
And as our source material explains so well, these standard distributions just give you the probability formulas you need on a silver plotter. Really, the hardest part is just learning to recognize your situation so you know which tool to pull out of the toolbox. So that brings us back to you. What's your version of the newspaper seller's problem? Maybe it's about managing inventory at work. Maybe it's deciding which projects to invest in. It could even be a personal financial choice. The point is, you now have the framework. You have the tools to stop just guessing and start building a real strategy based on seeing the whole picture.